Hello friends, welcome back to our channel. So in today's session we'll see one more operation in circular linked list, that is a deletion operation. So circular linked list. So already we have seen different operations, that means how to create a circular linked list, how to display the nodes of a circular linked list, and in our previous session we have already seen how to insert the element into a circular linked list. In that we have seen the three categories. So insertion at the beginning, insertion at the ending, and insertion at a specific position. So similarly we'll see the deletion operation in this session. So deleting an element from the beginning, deleting the element from the ending, and deleting the element from a specific position. So before that I'll just give 4 nodes. I'll write 4 nodes and directly we'll go with the deletion. So I'll post the links in the description regarding this create, display, and insertion. So go through that and just follow this one. So after completion of the theoretical part, I will explain, I will write the code and I will implement that code. Right? Now let us take the 4 nodes and then I'll start explaining how to delete the node from the beginning, ending, and at a specific position. So particularly in the data structures, so if you won't draw this diagram, it would be very difficult to write the code. So just you need to imagine more, right? So rather than that, just write down the code, draw the diagrams. Simply you can write the code. You need not mug up, right? So the address of first node 1000, address of second node is 2000, address of third node is 3000 and 4000. And in order to get the link, the address of second node should be here. So that is 1000, and address of third node should be in second node. So there will be link, there will be established a link here. So this is 4000, and the last node become, if this is a circular linked list, so the last node should hold the address of first node. So there will be a link from last node to first node, and this will be head, and this node will be a tail, right? So now our circular linked list is having 4 different elements, right? Now we'll see deletion at the beginning. So we need to delete the element from the beginning, that means the first position. Delete at beginning. So whatever it may be, deletion at beginning, ending, or specific position, one thing we need to check whether the circular linked list is empty or not, right? So delete at beginning, delete at end, delete at some position. For all these 3 cases, the first case, the case 1 is CLL is empty. We need to check for CLL is empty. For that, simply go if self.head is none. So if self.head is none, that implies there is no node in circular linked list. Simply we can write it is an empty. And coming to the second case, so if the circular linked list is having more than, one element, if it is having one element, simply we need to delete that particular element. If it is having one element, simply we can check self.head is equal to self.tail. If it is having only one element, this is the case. So simply you can write here, so self.head, it can be assigned to none. That's the second case. So first case, 0 nodes. So if it is 0 nodes, so we can't perform this deletion operation. So when it will be an empty, self.head is none. So that we need to check first. Second thing, self.head is equal to self.tail. That means there are nodes in circular linked list but only one node. So if there is only one node, the head and tail will be pointing towards the same node. So that's why we have to check this one. Self.head is equal to self.tail. Right? So if there is only one node, whether it can be deletion at beginning, deletion at end, or deletion at position, simply you can go with the self.head is equal to none. So you need not go with any other code, right? Simply self.head is equal to none, so that will be deleted. And coming to the third case, that means if the circular linked list is having more than one element, more than one node. So in case 1 is nodes, 0 nodes. Case 2 is only one node, and case 3 is having more than one node. So we need to check, or we need to write the code for the third case, that means more than one node. Okay, so don't worry, I'll execute the code. So we'll see all these three cases during the execution. I'll write everything, I'll execute the code and I will show you. Okay, so deletion at the beginning. Consider this example. So this is the third case, that means having more than one node. So it can be 2 nodes, 3 nodes, 4 nodes, 5 nodes, 10, 100, etc, etc. Okay, not equal to 1, more than 1. So simply what we have to do, so we need to delete this one. Okay, consider this example, delete this one. So if you delete this one, what will be the head? Head will be this one. So consider a temporary variable which is equal to head. Temporary is equal to head. That means assign the head value to the temporary, because so we need to traverse the head from one node to another node. So in order to maintain the problem perfect, so just assign one temporary variable. So head to some temporary variable. Now what we have to do, just move the head. So here after executing this one, the temp will also be pointing towards this node. So move the head towards the next one. So how the head can be moved to here? So head is equal to temp.next. So temp.next means 2000. So 2000 will be assigned to head. So obviously after executing this one, this head will be pointing here. Head will be pointing here, right? So now what we have to do, we need to discard this one. Okay, we need to discard this one. So, or before discarding, simply change the address of tail, because the tail will hold the address of first element. Now the first element will be head, right? So simply you can use tail.next. Tail.next means this value is equal to head. So what is the head value? 2000. So here 2000 will be replaced with 2000. So here the connection will be in this way. There is no connection for the first node. And here simply delete that one. Temp is equal to none. So obviously this will be deleted. This node will be deleted. This node will be deleted. So this is a small code to delete a node from the beginning. Okay, simply we are assigning head to temp and we are moving head to the next node because we are deleting the first node, right? So head is equal to temp.next, and then we need to change the tail because the tail will be holding the address of first element. Now after deleting the first element, the tail should hold the address of the second element because second element becomes the first element. So that's why tail.next is equal to head. So there will be a connection towards here. Then temp is equal to none, this element will be get deleted. Okay, the address will be deleted. Right. So that is the deletion at the beginning. Now we'll go with the deletion at end. So this is the head as usual, and this is the tail, and this will pointing at 1000. Now deletion at end. So this is also more than one node. So if it is more than one node, we need to delete the tail. Okay, we need to delete the tail. So we need to move the tail to previous node. Tail to previous node. So that means we can't change the tail to previous node in a simple way. So we need to traverse from first node to last but one node. First node to last but one node, right? So for that purpose, we are just taking a temporary variable and assigning the head value to the temporary. So this will be the temporary. Now we need to traverse this temporary variable from first node to last but one. So how can we move this one, right? So we can simply move with a instruction temp is equal to temp dot next. So in the first iteration, the temp value will be 1000. In the next, first iteration, temp is equal to temp dot next. So temp dot next. What is the temp dot next? So temp dot next is 2000. So here it will be 2000. Now the temp will be pointing towards the 2000. Okay. So temp will be at 2000. Next, again, temp is equal to temp dot next. Now temp is equal to 2000 to temp dot next means 3000. So now the temp will be at 3000. So we need to repeat that process until, see, you can observe temp dot next is 4000 and the tail is also 4000. So repeat these steps. So while temp dot next not equal to tail. Okay. So when we have to stop, whenever the temp dot next is equal to tail. So in this case, you can observe after 2 iterations, so temp dot next is 4000, which is equal to tail. So it will stop here. It will stop here. So we need to traverse the temporary variable from first node to last but one node. Okay, last but one node. So for that purpose, we are just writing here temp dot next until, repeat the process. So just move the temporary variable from one node to another node until the temp dot next not equal to tail. So whenever the temp dot next is equal to tail, simply stop the procedure. So stop the procedure. Now the temporary variable is in this position here and tail is here. So what we have to do, we need to remove the tail. We need to remove the tail. So simply you can see temp dot next is equal to, so instead of 4000, if you delete the last node, this will be the last node. So last node should hold the address of first node. So temp dot next is equal to head. Simply the 4000 will be removed and here there will be 1000. So this link will be disconnected here and it will be to the first node. Now what we have to do, we need to change the tail. Okay, so simply you can observe the tail is equal to none. So whatever the tail pointing to the node, that will be none. And assign the tail to temp. So tail is equal to temp. So now the tail will be pointing towards the temporary, that which is a last node, right? So this is a small code need to follow in order to delete the element or a node from the beginning, at the beginning, ending, right? Simply if you draw the diagrams, it will be very easy for you. So just traverse the temporary variable from first node to the last but one and simply disconnect the link and connect it towards the first node. That's it. Very simple. Right. Next, the third one, which is nothing but a position. We want to delete from the position. Okay. See. Take the 1000, which will be last one. So it is 4000 to establish the link, and this is the head and this is the tail. Now we are deleting at particular position. So here we need to give a parameter that is a position from where we need to delete. So just give the position as a parameter here. Okay, one parameter, that is a position. So what we have to do, we need to traverse, similar to our deletion process at the end, from the ending, we need to traverse the temporary variable from first element towards the last but one. And also here we need to travel two different temporary variables. See, for example, if position is equal to 3, if position is equal to 3, so what's the third element? 1, 2, 3. So this element should be removed. If we want to delete this element, okay, so we need to modify these two nodes. We need to modify these two nodes. So here we need to give the address of this node, which is available in this node, right? So we need the control of these two nodes. That means if the position is 3, we should be having a control of node 2, node 3, node 2 and node 3, right? And if a position is equal to 4, if we want to delete this fourth element, the control should be on node 3 and node 4. Then only we can modify the things. Then only we can modify. See, for that purpose, simple. Take the two variables. One is a temporary one, which points to the head, and another one temporary 2, which points at head.next. So simply you can observe this is temp1 and this will be temp2. Okay, temp1 is head, temp2 is head.next, this one. So just move till a position -1, till position -1. So this move means simply you can go with the temp1 is equal to a temp1 dot next, temp2 is equal to temp2 dot next. So this should be repeated until position -1. So that means, so range of 1 to position -1. For example, if the position is equal to 3, if the position is equal to 3, so here it will be range of 1 to 3 minus 1, 2. 1 to 2. That means only one iteration will be there. One iteration. So initially you can observe temp1 holds the 1000 and temp2 holds the 2000. Now only one iteration. Temp1 is equal to temp1 dot next. That means temp1 dot next means 2000. Temp1 will be 2000 and temp2 is equal to temp2 dot next. That means 3000. After first iteration, the temporary variables in this way. So temp1 points here and temp2 points here. So what we have to see, if I want to delete the third one, we need a control of 2 and 3. So 2 T1, 3 T2. So simply after moving this one, what we have to do? So temp1 dot next should be this value. That means the address of next node. So simply you can write, so temp1 dot next is equal to temp2 dot next. So temp1 dot next means 3000, right? So in that particular position, just give temp2 dot next. What is the temp2 dot next? 4000. So give 4000. So obviously this will be disconnected and it will be connected to this way. Okay, and again this connection is available, still available. So simply you can go with the temp2 is equal to none. So this element will be deleted. This element will be deleted and automatically the node will be connected. Right? So here one more case, that means if the position, if we are deleting the last element, what happens? The tail will also be deleted. So this is the code until we delete the element which is not equal to the last element. Okay, the position. If the position, now in this case, if the position is 4, what happens? So we are deleting the fourth. We are deleting the fourth position. But still the tail has been deleted, right? The tail should be moved to previous thing. So that's why we have to write the case. After this one, we need to write the case if temp2 dot next is equal to tail. Temp2 dot next is equal to tail. That means the last node is the tail. Okay, then simply see, if the position is 4, this will be the temp 1 and this will be the temp 2. Okay, so simply what we have to do, see, temp1 dot next is equal to temp2 dot next, temp1 dot next is equal to temp2 dot next. So simply 4000 will be replaced by 1000. So this link will be disconnected and directly this will be connected to the first one. But here the tail is pointing towards here, right? So tail should also be moved. So simply here we can write tail is equal to temp1. So obviously this tail becomes here. A small correction, right? So here we are just deleting at a particular position, the element at particular position. So here we need to take care about one more thing. If the position which we want to delete is the last element, we need to change the tail also. We need to change the tail also, right? So don't worry, don't get confused. I think there is a slight confusion regarding this deletion at the position. So I'll write the code, I will execute the code and I will explain you what exactly is being done. So it will be very clear for you. So just to draw the diagram and consider all the cases. So simply you can write this code. Now let's move on to the interpreter and let's execute these three cases. That means deletion at the ending, deletion at the beginning and deletion at the position, specific position. Let's move on to the interpreter. Hello friends. So just now we have seen the theoretical part of how to delete a node from circular linked list. That is from the beginning, at the end, or from the specific position. So now we'll write the code and I will implement the same thing for the three categories. That means deletion from the beginning, ending and position. First let us see the code in the previous session which we have written. So this is the code for creation and display. I am not using any add functions, right? So already in our previous session we have discussed about how to insert the element or node at the beginning, ending and specific position, right? So here I am just giving directly, I am writing some small set of code. So I have taken for some 4 nodes and I am displaying these nodes. So now the circular linked list elements are these are the elements, right? Now we'll see. So first we'll see how to delete the element at the beginning. So for that we need to write a function similar to our display function in the CLL class file. Okay, right. So I'll write here. So define or a definition delete underscore begin. This is a function I'm writing. So as usual, the first parameter will be the self, and we are not taking any element because directly whatever the node which is available in the beginning, that means a starting, so that will be get deleted. So before that we have seen 2 different cases. One is if it is none, so it should display that circular linked list is empty, and if it is having a single node, then obviously we need to delete that particular single node. And the third category, if it is having a more than one, then we have to write the code. So we'll write all these 3 cases, right? So first one, if it is an empty, right? That means self.head will be none. If it is there, just print no element or no node in circular linked list, right? And else, that means if there are nodes, so what about if it is having only single node? So we need to check that self.head is equal to self.tail. That means that particular node itself pointing towards the head and tail, right? So both will be pointing towards the same node. So that's why we are checking if the head and tail are equal. That implies it is the circular linked list is having only one node. So then simply you can put the head as none. That's all. So the node will be get deleted. There will be no link, right? And the third condition, that means if the self.head is not a none and our circular linked list is having more than one node, right? So these 2 cases are common for all. all the three categories. That means deletion at the beginning, deletion at the ending, and deletion at the position. So now the actual code will comes. So first let us take a temporary variable pointing towards the head, because so we are just moving the head to the next node. That means if we want to delete the first node, now the head should point to the second node. So we need to do some sort of operations, right? So in order to change the head, so we can take this head to one temporary variable. Now simply initialize the head to the temp.next. Okay, the temp is head and temp both pointing towards the same node. That means the first node. Now what we have to do? So the head should be moved to next node. So that means temp.next should be assigned to head. Now the self.head is pointing towards the second node. Now the first node is temp. So that should be none. That should be none. So temp is equal to none. Simply you can write temp is equal to none. And what about the tail? So tail pointing towards the last node, and the tail dot next will be the address of first node. But here we are deleting the first node. So now the head is at the second node. Now tail dot next must be self dot head. The head should be at the tail. Self dot head, right? Yes, that's it. Simple. So we are just moving the head towards the second node. We are keeping the none for the first node, and we are changing the address at the tail node, right? At the last node, the last node should hold the address of first node. So that we are assigning. Now we'll check. So I'm executing this one. Oh yes, double is equal to. It's not a assignment operator, is it? Comparison, right? Yes. So now we are having the linked list elements. Now I just delete L dot delete, because L is a object created for this particular class. So whatever the methods we are writing inside the class, that should be called with the help of this object. So L dot delete, we have written delete underscore begin. Yes, delete underscore begin, and let us display this one after deletion. Oh, there is some sort of error. Tail is not, yes. So here we need to write self dot tail. Yes, see, you can observe. So 10 has been deleted. So after performing this begin, the 10 has been deleted. The 20 will be the first one. And see, you can observe the last element is having the address of the first node. Okay, the last element will be having the address of first node. So once again we'll apply the same thing. Now what should be deleted? 20 should be deleted. You can observe 30 and 40, and 40 is the last one, so that will be pointing towards the first node. That is a 30 again 40, only single element, only single node. And again if you apply, see, circular linked list is empty because everything has been deleted. Everything has been deleted, right? Hope you understood. Very simple thing, very simple thing. Now we'll see deletion at end. Okay, so we have already seen everything theoretically on board. Just I am implementing this one, delete underscore end. The one thing is self, and here also the same thing. So first we need to check for an empty node, empty circular linked list. If self dot head is none, that implies simply you can write it here. So no node in circular linked list, right? And after that simply go with the else part. That means if it is having more than one node, I mean if it is having node, we need to check for a single node, right? If the circular linked list is having the single node, then we need to delete the same node. So I am verifying that self dot head is equal to self dot tail, right? And then if it is there, self dot head is equal to none. That means directly I am assigning a none value to the head, or else that means more than one value. Then we need to delete the last element. Okay, last node. So in order to delete the last node, we have to traverse the head from starting node to the node just before the tail, because we need to update the node which is just before the tail, because we are deleting the tail node, right? For that, just create a temporary variable, assign a head to the temporary variable, because we are just moving the we should not move the head. Okay, the head should point to always the first node, right? So that's why I'm creating one temporary variable. Now we can move the temporary variable up to where? So while temp.next not equal to self.tail. That means you can observe, if the temp is pointing towards last but one node, that will be holding the address of tail, right? So last but one node is addressing, is storing the address of last node, right? Tail node. So that means we need to repeat the steps until the temp.next not equal to self.tail. So what we have to do, until this becomes false, we need to move the temp value to temp.next. We are doing nothing, just we are moving the temp value from next node, right? We are traversing the temp value, the temp the pointer from starting node to tail before node. Okay, node before the tail. Now after executing this loop, after completion of this particular loop, that the temp is pointing towards the node just before the tail. That means last but one node. Now what we have to change? So simply you can initialize self.tail is equal to none, because we need to delete the last element. We need to delete the last element. And after removing this one, that means after executing this statement, there is no tail. There is no tail. What happens now? The temp is pointing towards the node just before the tail. So that means whatever the temp is there, that will be the tail. Okay. So self dot so self dot tail is equal to temp. Now what happens? So here the last but one node is still having the address of last node which has been deleted. What we have to do? The last node should store the address of the first one. So what we have to do here? So temp.next, or simply you can go with the self.tail.next. Okay, temp.next or self.tail.next should be head. That's it. That's it. So simply you can observe, see here we are having the thing. So L dot delete underscore end and L dot display. You can observe. So 40 has been deleted because the 40 is the last node. So it will pointing towards the first node. So 40 will be deleted. So now 30 will be the last element, and again this 30 is pointing towards the first node. Once again, I'll just copy and I'll see. Now 30 has been deleted. 20 is the last node. 10 is the last node. And also 10 is the single node. Once again, I'm deleting. So circular linked list is empty. So there is no node. There is no node available in the circular linked list. So that is about deletion at the end. Now the third category, yes, we need to go with the another category. So that is deletion of an element from a particular position. So we need to take two arguments. One is a self default and another one is a position from where we need to remove the element. So first we are checking whether the linked list is empty or not. So if it is empty, self.head will be none. So I'm checking this condition. So simply you can print here. So no node in circular linked list, right? And also again we are also checking for one more condition. If position is equal to 1, so we need not write any sort of code. Simply you can call the function. So delete underscore begin. right? So if we want to delete the first position 1 node at position 1, that implies we are deleting, we are trying to delete the first node. And then the next one, if we are having a more than one node, so we need to take a two variables here. One point out towards the head, that means the first element, and another one points towards second element. So second element address will be self.head.next. So we need to traverse these two nodes, temp1 and temp2, till the position, so for that we are just moving I in range from 1 to position -1, right? So just traverse both the nodes. Temp1 is equal to temp1.next, and temp2 is equal to temp2.next. So after executing this loop, temp2 will be pointing towards the position, that means where we want to delete. If the position is 3, after completion of this for loop, temp2 points towards the third element, and temp1 points towards the second element. And if the position is 5, okay, if you want to delete the fifth element from the circular linked list, the temp2, after executing this for loop, the temp2 is pointing towards the fifth node, and temp1 points to the fourth node. So we want to delete the position, the element at the position, right? So temp2 should be deleted. So whatever the address available in temp2.next, that should be present in temp1.next. So temp1.next is equal to temp2.next. And here we need to check one more condition. If the temp2 points towards the last element, if it is the last element, we need to change the tail, right? For example, if you want to delete an element from the, position 5, and if the fifth position is itself is the last node, then by removing the fifth position, so one problem is there is no tail. Okay, so there is no address stored. We need to move that one. So that means we have to do self dot tail. Sorry, we need to check the condition, right? If temp2 is equal to self dot tail, okay, self dot tail, then simply self dot tail should be temp1, and temp2 will be none, so it will be deleted. Now let us check here. We need to check whether the code is working. Yes. So execute. There are four elements. So here we'll go with the delete underscore position of 3 or 2. Okay, 2 means 20. So delete underscore position. We are having this delete underscore position L dot delete underscore position. Oh, indentation is wrong. Yes. So here the indentation is wrong. So I'm sorry. So we need to change all the indentations. And here. So be careful while giving the indentations. So if one indentation is wrong, obviously we'll not get the 4. Yes, right. So execute. Let us take this display function. See, second element has been deleted, 20 has been deleted here, and if you go with the 3, see 30 has been deleted, and if you go with the 4, 40 has been deleted, right? Afterwards, I am just deleting at the beginning, right? So after deleting the 40, I am deleting beginning, right? So this what happens. So I am first we are trying to delete the fourth node, which is a last element, right? Afterwards, again we are deleting the beginning element. So that means at 10 we are deleting. So after deleting the 10, 20 will be the first element, right? Now we'll delete the ending element. See, end means the end element is 20. Sorry, 30. 30 is the end element. So 30 will be deleted. Hope you understood this one, right? So here, so only one thing we need to remember: if the position which we are trying to delete is the last element, then we need to change the tail, because the tail will also has been deleted, right? Yes. So hope you understood this one, and if you are having any doubts in this code, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.